this is kind of the catchment of the Cockshut. So the Cockshut is part of what's called the Iford Marshes. So Iford Marshes is pretty much all the marshes that you can see. So very well named. A long time ago, which has then shaped it. So you can see the restoration project there is kind of the end of the natural bit, and then it goes under the A27. It basically turns right angles, goes along the back of Lewis tennis clubs, and then it enters the ooze down there. So that's one part of the Cockshut. It also releases all the water that then goes into the brooks. So there's a channel which we'll see when we go down there called the Celery Sewer, which then feeds all of this brooks with all the water. So all of that is, most of that is a triple SI, so it's a site of scientific interest, special scientific interest, for its wetland features, for its ditches. Unfortunately, not much of why it's been classified is there anymore. So we've done quite a lot of surveying. So obviously the plans are, how do you kind of turn this area back into what it should be really? So we'll start history, like a bit of history. So if you look out at this is a man-made landscape. So we've created this. This is not natural in any way whatsoever. Obviously the downs bit, the lumps are, but the bit in the middle is completely artificial. So effectively, years ago, about 8,000 BC, it's marsh. It should be marsh. It actually was all alder. It was all a big bit of alder karst. So the whole thing was wooded and as a swamp with lots of braided channels going through it. So lots of very tiny little tracks. So no river channels as we imagine them today. Just water working its way through the landscape. All the downs was covered in trees as well. So all of this was wooded. Everything was woodland. And basically, when us humans came along, stripped all the trees off the downs, and that enabled all the soil that's on the downs all ran off down into the valley. So this would have been basically peat. It's chalk, and then it's peat underneath there. So there's about 3.5 metre layer of peat, which is all the decaying old woodland that used to be down there. So we've done lots of surveys and lots of lab work around what it all was. Lots of historic pollen, so we know what all the vegetation down there was in the past. So it was all woodland. As that woodland decayed, it became peat. So you had these kind of peat bogs, and what you see quite a lot up in the north of the country now. And then we stripped all the trees off the downs. Well, we didn't, obviously, but our ancestors stripped all the trees off the downs. All the topsoil fell off the downs, went down into the valley, and there's about 1.5 metres of soil down there now. That's not suitable for the habitat that was down there, so it killed everything. And created this kind of area of grassland, but it was still marshy, so it's just changed it from kind of a peat bog into more of what you think of as a traditional wetland. Still no channels going through it. And then around about the 11th century, we really started to mess it up. So we then, it was then massively changed and drained, mainly around the construction of the priory. So the priory, and they started to canalise it. So they started to put channels in, so you could put boats into and out of the priory. About the 17th century, we then cut all these drainage ditches into it and started to put lots of structures in it to control exactly where water went, start to drain it for agriculture, so you could start to graze it. And then in more recent times, we built the A27, which then moved the entire stream. So the stream where it sits, even before we did this project, as you get into the valley, it shows no relationship to any of its historical courses. So as a brief kind of history, it's just quite interesting to kind of, you sort of think it's really, it's quite an old landscape, but actually it's been hugely changed and modified. And with water, nobody likes water, so we tend to push it to the edge of fields. So we kind of push it into really straight, long channels. That's no good for, well, rivers or ecology or chalk streams or any of it. They like to spread out, they like to move around, so we kind of try to contain it. So what you're looking at here is effectively, the kind of the start of that catchment. The whole area drains to the River Ouse, which is over there. But the Cockshut is only about 11% of that water. So only 11% of the water that gets to the Ouse comes from here. The rest of it comes from other springs down there, springs down in the ground. If you imagine groundwater is moving like surface water. So underground, the water is still flowing, it's flowing through lots of channels, but it's flowing through chalk, and chalk is really erodable. So as the water flows past it, it breaks it down and it kind of erodes it. So periodically, you'll just get a spring that just suddenly appears. The chalk will just collapse and you'll get a new hole in the ground and water will just start coming out of it. So these chalk streams move around. They move around, and so one will disappear, one will turn. Not annually, clearly, but periodically these things change. Which is why managing water and surface water and what's coming down into Kingston can be quite tricky, because you think you've got a handle on where the water's going to come from, and then it changes. But basically it's pretty man-made now. It's pretty structured. You see, we'll go past them, but I'm sure the ponds down the bottom there. It's kind of, so the water comes, it's mainly underground, and then it pops up near the ponds, and then it goes down towards the restoration site. So everything this way is going into the Cockshut, and obviously everything that side is going into a completely different river catchment in that direction. So these springs that we're interested in, and how the water flows through this valley, is what we're interested in. Underground streams, and they're all heading into this valley point here. So it's not a great water walk at the moment. When you get down there, there's something there. If you followed the project at all, you'll hear us talking a lot about something called parrot's feather, which is it's an invasive plant species. It's really bad. It's like you get it and it just, you can't get rid of it. It's really hard to get rid of. So, but you can buy it in garden centres. So the parrot's feather down there, which is spreading over the entire triple SI and the brooks, originated in a pond in Kingston. So somebody bought it, this is not, you can't point fingers, you can legally buy this stuff in a shop. So it's not, nobody's done anything wrong. But effectively, from the tiniest fragment floating out of the pond when it rains and the pond fills up, you need literally a millimetre of it. It comes down the system, ends up down there, and it just spreads. And once it's established, you can't get rid of it. So really, again, this is just that kind of impact of, we're doing a lot of work with garden centres around, why are you selling stuff that we're trying to, but it's really important that if you are buying things in garden centres, we've just talked about gardening and manicured gardens, and that you kind of really think about what you do with that waste, that garden waste, because actually a lot of it is really harmful in the environment. Lovely in your garden, we've all got gardens that we're very proud of, but if it gets out into the environment, a lot of it really detrimental. We know that some of the problems down here originate from up here. You're also starting to see the effects of that kind of road runoff. This is culverts, this is drainage that's coming out of Kingston. So it's like it's a really interesting area, Kingston, the village, because you are sitting right on top of a water environment that you can't see, and this is what I meant before about that kind of that behaviour and that we were talking about, kind of what can people do, and it is really thinking about everything that goes into your drain. Not everything comes out here, but some of parts of what's happening up there are directly coming out here, and then from here. It is going straight down into that. Yeah, well, it's affecting the water, but this is still part of the stream. This is really good. We like this. This is not a problem. What we don't want is it on both sides. But this is really good. These kinds of habitats are absolutely phenomenal for dragonflies, beetles, all kinds of stuff. So what we don't want is things that look like that. We want banks and profiles that are all different. So nature, messy. Anything that looks like it's been built is not performing as it should be. So there's no problem with this, what you're seeing here. The growth of these things in the channel, really good. This is trapping any of that stuff that's coming down. It's pushing the water in different directions. It's allowing it to kind of change and move around. So what we don't want is people coming down with diggers and like scraping everything out the bottom of the ditch and straightening it. Ideally, this wouldn't be straight, as a ditch, but it is a ditch. Ideally, it would come out into the field, or it would be moving around a bit. But yeah, you can start to see. You're now starting to see the kind of formation of that chalk stream. It's kind of that, obviously it's right next door to the road, and the whole road cambers this way, so everything that lands on that road or comes off of these driveways, off of these roofs, all comes this way, and is all getting into this kind of channel, which is then walking down that way. And it's one of those things that falls into that black hole of management where nobody thinks it's their responsibility to do anything. See how these branches are going down and then they're coming up into like a big J shape. So this tells us a lot about the history of the stream, because it basically means that it's one of the signs that there's always water in it. So as the trees come out and they grow down, as soon as they hit water, they obviously don't want to grow into the water, so they start to grow upwards. So the bigger kind of J shapes that you get gives you really information about what's happening in the water environment. So you can see that this thing should have a pretty much constant level to it. If it was a natural stream rather than getting lots of runoff from the road, it would have a pretty constant level. It wouldn't change that much. So you can almost tell what that constant level should be by where these trees sit. So it basically says there's been water here for a long time. But yeah, so you can see even down in this part, you get periods where the water pressure is so much, there's so much water in the aquifers. It's not quite so much nowadays because we pump a lot of it out to drink it, but historically, you get even springs appearing right down in the valley bottoms here. So I think it starts to get a bit more natural now. It starts to kind of open up. So this next bit, you can see the reeds. So that's kind of following the line of it. Really great habitat. Again, messy. We want messy. We want lots of different things going on. So we don't want everything clear in the same habitat all the way down. This is a bit too messy, what we've just walked along, and a bit straight, but it's different. So this is different than that, and that's what's giving you the kind of diversity and the kind of habitat that you want. So this is really valuable. You could see open water as well as the kind of watercress, whereas now it's becoming a bit of a blanket. Less ideal, but you need to kind of just slightly change the gradient of the bed and you'd actually see that flowing water coming through it. But as a part of that habitat network and diversity, little patches like this are not really a problem. If you cleared all this out and this went all the way down, it starts to become a bit more of an issue. But you know, where you've got such different vegetation structures, really good. So yeah, but you can see any bit of open water, vegetation will just grow in it. But it's not really a sign of nutrient enrichment. It is what you should. It's what these streams become. But you're starting, so this is now part of the bit that was sort of shoved to the side when they built the A27. The reason they did it is because they basically filled in the old stream with a lot of the risings from the A27, and some of the servicing, some of the cabling and stuff kind of went there. So they basically kind of shunted it this way and straightened it. So it kind of meandered and wiggled through there, and then so whenever the A27 was built, it was kind of the final bit of the destruction of the Cockshut. So then it started to look like this. So what we did, I don't know if you, I'm sure you became that. So this was just a straight line that went all the way along the back edge of this field. It looked like this the entire way, until it got to the A27, and then it goes into a pipe, and then it pops out the other side and is even worse. But let's go and have a look. This water that's coming through and all this water that's sitting up there, that is effectively the old course of where it was realigned to. We've done this to drain, this is drainage that's coming from the cricket club. If we stopped that happening, we'd flood the cricket club, which is not a popular thing to do. So the reason why, but you can see how much water and the groundwater, I mean, I know it rained last night, but it hasn't rained for quite a long time. So you can see how high the water levels are. This is all just coming out of the ground of the creek. But again, it's creating really nice habitat down that way, so we're getting some nice kind of marginal habitat. But what you will notice here is it's completely still, so it's completely, there's no movement. If you think where we were up there, it was flowing, we could see it moving, and when you get here it's not. There's two reasons for that. Reason number one is that it's completely flat here. So this field has got a 1 in 3,000 slope in it. So it drops 1 metre for every 3 kilometres. Gosh. Which is flat. I mean, that is flat. So A, there's no movement because of the gradient, and B, at the other end by the A27, it's stopped by a big concrete pipe. So there's a pipe that drains it under the A27, and the pipe is much smaller than the river. So if you think this is the size of, you know, everything's this size, and then all of a sudden it's trying to get through a pipe that's about this big under the A27. So clearly the water can't get under the A27 as fast as it's coming in, so it all gets backed up. And also then about 1 kilometre further down it hits the River Ouse, and the River Ouse is controlled by a tidal flap, so it's got a flap on it that stops water going into the Ouse during high tide. So obviously there's 2 high tides every day, so it's around 16-17 hours of the day, no water leaves this area at all. It's all stuck in here. So then it goes that way. We're going to have a look at that. So, but that's why it's kind of slightly changed. Now you'll see as you go around, you'll see all this algae and stuff. Yeah, this is we expect this. So this is not a water quality problem. Well, it is a water quality problem, but it's a water quality problem that we've created because we've dug out around 16,000 tons of soil, or 16,000 cubic meters of soil out of the ground. And as we've done that, we've disturbed all the soil bed and all the seed bed. So we've released lots of nutrients and lots of historical stuff. So we expect for the first couple of years for it to look a little bit messy because all that nutrients have been released. It's warm, it's creating these kinds of little bits of algae. It's not a problem, it will all go away, it will all settle back down. As all the sediment and fine particles sit back down on the bottom again, it will all disappear. Luminous green things that are starting to appear over there, so that's parrot's feather. We're hoping that if we get on top of it, and as the vegetation establishes, and if we manage the rest of the site properly, the establishment of other vegetation will outcompete it. I was saying to somebody on the way down that we've planted nothing in this channel, so we seeded all the ground around it, but everything you can see that's got water on it, we haven't planted anything in it at all. So what's appearing, and if you look down here, you can see these starworts. So that's a starwort, so another chalk stream kind of species. It's all appearing from the natural seed bed, from the historic seed bank of when this was a marsh. But obviously we wanted to move the stream and get it a bit more healthy, but mainly to get back some of the features of the triple SI. So it's a triple SI for its dragonfly species. It used to have little ramshorn snails here, some of the brook stream vegetation, and some of the bird species, and none of it was here when we started. So the mission was to try and build habitat that attracts those designations back, because we don't want it to become undesignated. You know, if you start to, you know, we don't want them to suddenly go, well, none of the reasons why it's protected are here anymore, let's not protect it. So we kind of want to try and boost the area back, and obviously with what, you know, Ben's doing down at the Iford estate and, you know, the bits in between, you know, hopefully you can get a really nice kind of positive environment kind of back down in this area. So it's really been designed to be managed in a way which is quite hands-off, but the bits you are doing are really important. So that's what we need to keep going. So we had to lose the soil, so we calculated, obviously we infilled the old channel, we had a deficit, so we needed to do something with it. So we bought, well, we thought doing this would be quite nice because it's nice for people to walk on it. I know in winter it gets a bit muddy and a bit mucky. We were not allowed to pave it, put any hard standing surface on it. We weren't, you know, this is in the national park, it's a triple SI. Both the planning authority and Natural England just went, no, you know, you're not, it has to be completely natural. So I know that is difficult, and it's a shame because it makes it slightly less accessible. That's not been touched at all. That's exactly as it was before. So that's the original kind of land level. So this here is where the water's leaving the site. You can see it's leaving the site this way. So there's a pipe that goes out there. This pipe was always here. If you look straight across there, you can see the other, directly opposite us, there's another little channel that goes that way, which was the other. So this was a ditch that just went that way from the old channel. So we've maintained that. This pipe here, at the top of the concrete, don't jump in there, it's quite deep. But that pipe is about a metre diameter, so it's quite a big pipe. And it's got lots of boards in it to control water levels. So in winter, because this is all triple SI, we had to make sure that we maintained the same levels of water in that direction that were there beforehand. So this is all set so that the same amount of water leaves the site now as it did before. And these boards are in there so that we can control that level. So effectively, if we have a really dry summer, for example, and all of this starts to dry out, we can take some of these boards out and we can push some of this water down into the brooks. It's all flooded at the moment, obviously, but if it drains down, or as it drains down, you'll start to see just pools of water that will appear. And then there's a channel that goes through the middle. So if we do have extreme drought and extreme periods of time, all that water still condenses into a depth and a channel that will hold life in it. Because you need 15 centimetres of water basically to kind of keep things going. Because it looks like it's really deep, but actually it's not. You know, most of it is probably got about this much water in it. So the deepest point of it, so the channel that we dug obviously comes in under that bridge, and then it goes behind that island, and then it kind of wiggles through the land thing. That is, at its deepest, it's only 50 centimetres deep. So the deepest point in here is about 50 centimetres deep. So whilst it looks like it's like some kind of reservoir, it's not. And obviously, as this vegetation, so this vegetation here is growing up really nicely. As this grows up more and more, you'll end up with more of this kind of marshy environment that we were talking about at the start. So that's so all of that stuff I was saying at the top end about all the nutrients, and obviously we've then blocked it. So all the nutrients that have come this way have ended up here, which is why you've got this duckweed, which is grown here. So this is nutrient enrichment, but it is by us. And again, we are monitoring what's happening with the water. We need to really kind of focus on the positives. There's so much negativity around rivers and water. You know, let's celebrate the positive stuff. There's so much action going on at all kinds of scales. So